a set of differential equations. Actually, these differential equations came from displacement and velocity of a swaying building. But let's just go on and do it. So it says with a step size of 0.2, we're obviously going to be using Euler's method. We've got initial conditions, and we need to bash out to t equals 10. So we need our spreadsheet. So doc, insert our spreadsheet, and I'm going to go x variable, v variable, gx, gradient of x, gv, and of course we could do with a t first. I'll go back. T here would be better than at the end. T, x. Why is it showing me solid x here? So it types x in. So if I press x here, okay, it's superimposed. There was no data entered for x, so we're okay. Good. T, x, v, gx, and then over here, gv. Perfect. So let's go back here, and now this is going to be a 0. The initial conditions for x was 3.9, negative 0.1, and then the gradient of x, gradient of x is just the v value, the velocity value. So in here is equal to the v value, which is in C1, enter. And I think this last one was negative 1/3 of each, right? Negative 1/3 x minus 1/3 v. So in here equals negative 1/3 times by the x coordinate in B1, and then subtract 1/3 times the v coordinate, which is in C1. Perfect. So we then click and highlight the two gradients, menu data, fill, and we fill down just there. Of course, there's no numbers there because we now need to do this. Now, here's where I'm going to change a little bit because the step size is going to be 0.2 initially. But what if we want to change the step size later? We then go and have to type in again these formulas and then fill down again. So the magic is doc, insert a calculator, 0.2 the initial step size, control, store it as variable s. Let's go back to the spreadsheet. So now in here, what do we want? We want equals A1 plus the step size, S. I put 2. S. All right. And now in here, equals the previous x value, B1, plus the gradient of x, which is D1, times by the step size. And in here equals the previous v value, which is in C1, plus the gradient. Now the gradient, remember, is in E1, times by the step size. And now we go and highlight all of this row, the gradients all the way down to here. We are menu, data, and we are fill. And then we fill down. Obviously, my fill down is going to be a little bit quicker than yours, but that's okay. Pretty much I've got more than enough there, but this is just for illustration purposes. Great. So that's all worked out nicely. And now let's go and have a look at it. Well, the first question is about t equals 10, right? So let's go down to t equals 10. There we go, t equals 10, we've got an x and a v. X, positive displacement, positive velocity. So we might like to think about what that means in the context of the question, the swaying building. Let's go and see the graph. Insert a... Now you can go data and statistics, but I think we're happy to go to graph. And then when we plot from here, we're going to plot a scatter plot. This was x and this was v. Oh, look at that. It's beautiful. Beautiful graph. All right, so let's menu, window zoom. Let's go zoom in. Glorious. Now let's go to the magic, because actually I want the step size now of 0.1. So previously we'd have to go all the way back to here, and we'd have to change a few formulas, right? We'd have to change this formula, this formula, this formula, and then we'd have to drag and copy down again. But now, watch the magic. Ready? 0.1 we store as S. Let's go back to our spreadsheet. Oh my words. Automatically updated all the way down, right? Now let's go down to t equals 10. Well, obviously it's not t equals 10 anymore, right? So the only thing we have to do now is, all the formulas are in, we might then have to highlight and fill down from the last entry point, menu, data, fill, but that is way quicker now, right? Yeah. And then we can just keep updating that step size and see what effect it has on our predictions at t equals 10. And now our graph, of course, is just a lot cleaner and tidier, isn't it? It's a lot tighter. All right. So that is basically create a calculator menu, put your first step size in, store it as variable S, and then go back to your spreadsheet. Now everything in terms of step size relates to variable S. You're very welcome. Nice.